Hi everyone, I'm Rana Mohammed of First MCA and my seminar topic is Introduction to Component Level Design. First of all, what is component level design? Component level design is a critical phase in software design. Here, instead of dealing with the system as a whole, we systematically break it down to smaller, manageable parts, which we call components. Hence, why we have the name as component level design. Here, each component represents a specific functionality of the system and is designed in detail so that it can be translated directly into working code. Now, we have all learned the different phases in software development. So, component level designs comes after requirement analysis and system design. In requirement analysis, we mainly gather and analyze the system requirements, and next, in system design, we come up with high level architecture and structure for the system. And only after this, component level design comes in. Here we come up with detailed design of every individual components of the system. And only after this, we move on to the coding phase. This is where we translate the design into actual code to implement our design. So we can say that component level design acts as a bridge between design and coding in the software development lifecycle. Now that we have an idea of component level design, let's discuss what basically is a component. A component is defined as modular, reusable and independent unit of a software system that performs a specific function. Now let's take a look at some examples. So we have a login module. The login module is responsible for handling user authentication. So it takes username and password as input, it checks if the given details are correct, and it allows or denies access. So this is a component because it performs one specific task and it can be reused in different systems and it works independently from other parts. The second one is payment processing unit. When we buy something online, the payment component handles the transaction without affecting other parts like login or profile. The next one we have database handler. This component manages data storage and retrieval, and it handles only data operations. Other components may interact with it but don't control its internal working. So we have seen that each component performs a specific task, has well-defined inputs and outputs, and can be developed and tested independently. As we have seen in this example, each of these components have a specific responsibility. Login handles authentication, payment handles transactions, and database handler manages data. Together, they form a complete system while still remaining independent and reusable. Let's take a look at the objectives of component level design. Some of its main objectives are decomposition, simplicity, reusability, maintainability, etc. Decomposition means to break complex system into smaller manageable parts that are easier to understand and work with. Simplicity makes the system easy to understand and implement for developers and maintainers. Reusability ensures that the components are reusable across different parts of the system or in future projects. And maintainability, to improve maintainability and testing by isolating functionality to discrete units. Here are some of the key concepts that we need to understand while learning component level design. These are some of the important terms. The first one is cohesion. It measures how closely related the functions within a component are. So high cohesion indicates good design where each component performs one specific task. Second one is coupling. It measures how dependent components are on each other. So low coupling indicates good design. Low coupling means the components remain independent and loosely connected. The next one is modularity. As the name suggests, it divides the system into smaller modules or components. Its benefit is it becomes easier development, debugging, and parallel work. The next term is abstraction. It means showing only essential details and hiding internal complexity. As you have seen in the previous example as well, user sees a login form but not the authentication logic. And the last concept is encapsulation, and this is another concept that we have learned before. It is combining data and functions into a single unit and restricting access to internal details. Component level design process. Here are the various steps involved in component level design. The first one is identifying components. Here we extract components from system design specifications. At this stage, the overall system is broken down into smaller components based on the high level design. The second step is defining interfaces. So each component must clearly define what input it receives and what output it produces. This is called the interface of the component. It ensures smooth communication between the components. The third step is designing logic. So here we decide how the component will actually work internally. We design the step-by-step logic. This can be done using pseudocode or flowcharts. We also choose appropriate data structures and efficient algorithms. And last but not least is documenting the design. As a final step, all design decisions are properly documented. Let's take a look at some of the advantages of component level design. First one, improved code quality. Well-defined components lead to cleaner, more organized code. Next, easier testing. Since the whole system is divided into various components which are independent, they can be tested independently before integration. Parallel development. Multiple developers can work on different components simultaneously. Increased reusability. Components can be reused across different projects and systems. Simplified maintenance. Isolated changes reduce risk of breaking other system parts. Let's talk about some of the limitations of component level design. First one, planning requirements. It requires careful upfront planning and analysis to identify appropriate component boundaries. Next one, complexity for large systems. In case of very large or highly interconnected systems, it becomes really difficult to manage all the different components. The next one is design quality impact. Poor design decisions may result in high coupling and reduced flexibility. Now, these were some of the limitations, and with that, let's come to conclusion. So, component level design is an essential step in software engineering that focuses on detailed design of individual components. By following good design principles like low coupling and high cohesion, developers can create systems that are efficient, scalable, and easy to maintain. Thank you.